So question 11, right? Elevated temperature methyl isonitrile isomerizes to acetonitrile, first order reaction. We also knew it was a first order reaction because we've got natural log of pressure, and we know for gases, natural log of pressure, we can look at that as our concentration. So natural log of pressure versus time, and that's a linear relationship. So we know we have a first order reaction based on that. The one trick though, and this is similar to the problem we worked through in class, is that in this graph, the data we have is natural log already. They already did that step of taking the natural log. So right, our equation would be natural log of concentration at time t equals negative kt plus natural log concentration at time 0. And this is where the trick sets in. They want to know the rate constant for that reaction, K. So I picked these two data points. I picked 5 because that's my initial concentration. But looking at the graph, it is the natural log of my initial concentration. So we can just plug in 5 directly into that equation. And I looked over here and I saw that at about 4, the natural log of 4, this intersected the graph at about 20,000 seconds. So I happened to pick this time and that natural log of concentration for the future calculation, or for the future concentration, because this was very close to 20,000 seconds and very close to 4, the natural log of 4. So we can skip that first step and just simply plug in, okay, 4 equals negative K. I need to find K, and that happens at 20,000 seconds into the reaction. And the natural log of my initial concentration, or natural log of my partial pressure, right? I already have that as well. I can take that number right from the graph. So everyone follow that first step, how we don't have to take natural log because that's what's graphed. They already did that for us. So subtract 5, right? Makes our math a lot nicer. Yeah, just a second, Ali. We get -1 equals negative K, 20,000 seconds. And what's your question?
So when would you have to put it into natural log?
Yeah, if I gave you like a data table of concentration versus time, and it was just concentration versus time, like question 9 and 10, it was just a data table, and it said, here's the time, here's the concentration, and it told you this reaction's first order. So then we had to take the natural log of that concentration. Whereas here we have a graph, they did that for us. They've already taken the natural log. So just like the previous question, right, we can divide by a negative 20,000 seconds.
So since you know that it's first order, that's when you're on the chart, you know it's first order, that's what you know.
So in question 9 and 10, they said, given this data and it's a first order reaction, they told you in the question. Here we know it's first order. I didn't read the question closely, but here we know it's first order because on the y-axis it's natural log and it's a linear relationship. It's a linear graph. So we divide by 20,000 seconds, right? And I get a rate constant of like 5 times 10 to the minus 5 inverse seconds for that reaction. So yeah, this one makes it a little bit trickier because you have to pull that data from the graph. I'm not going to make you do that on the exam because I made that mistake before and realized that students were picking like all different kinds of points, and that made their calculations a little bit different, a little bit farther off based on how they interpreted the graph, which made it hard to get to the right answer. So yeah, but this one, 5.0 times 10 to the negative 5 for our rate constant for that. Yeah.